Hi everyone, I'm Noa Garcia and I'm going to introduce our paper Knowledge-Based Video Question Answering with Unsupervised Scene Descriptions, a joint work with Yuta Nakashima at Osaka University. In this paper, we address video story question answering, which consists on providing a correct answer to questions about a movie or a TV show. For example, let's look at the following clip.
Indy's whip snapped, Thor's hammer missed. It was Avenger versus Archaeologist.
A possible question could be, what instrument is Rush playing? And the answer in this case would be guitar. The first dataset introducing video story question answering was VideoQA in 2016. Questions in VideoQA are mostly about the general plot of a movie, as annotators were asked to generate them by looking at a summary of the movie. This means that there are not many questions about dialogues or actions of the specific scenes. In 2017, VideoQA dataset was introduced with questions about a cartoon TV show. In this case, questions were about the dialogue and actions in a short video clip, but did not consider the general plot of the story. Similarly, in TVQA dataset, there are hundreds of thousands of questions about several TV shows, specifically designed to be answered with the information that can be seen and heard in a specific scene, without considering the overall plot of the show. More recently, KnowIt-VQA dataset introduced both questions about the overall storyline as well as specific questions about the scenes, such as actions or conversations between characters. To address this level of question diversity in video story question answering, the task of knowledge-based VideoQA was introduced. In knowledge-based VideoQA, three different sources of information are used to answer questions: the dialogues, the visual frames, and an external knowledge base with information about the plot of the movie. Usually, this knowledge base is generated by human experts and contains sentences that can be handy to understand the plot. To predict the correct answer, the dialogues, the video frame information, and the knowledge are used together with the question and the candidate answers in a QA module. In this work, we propose a novel model to address video story QA, which name is role and is based on this structure with some important modifications. Role has three branches. The red branch is for dealing with dialogues, the observe branch for processing video frames, and the recall branch for extracting external knowledge. The first contribution of role is that the observe branch generates descriptions of the video clip in an unsupervised manner to represent the video content. The second contribution of role is that the knowledge base is not generated by human experts, but obtained as noisy large video summaries from the internet. Last, the third contribution of role is that it uses a late fusion mechanism with a modality weighting scheme to balance the contribution of the different sources of information. Now, let's take a look at the details of each branch in detail. The read branch is the one that deals with subtitles. Nothing fancy on this branch really. It only takes the subtitles from the input video clip for further processing. Let's move to the observe branch, which is a little more exciting. The observe branch generates a description for each video clip without using any sentence description annotations. To do that, we first rely on detecting four key scene semantic elements, which are the characters, the location, the objects, and the relationships, and also the actions. Once these elements are detected, we apply temporal filters and build a video scene graph. The video scene graph is used as the basis of the scene description. We generate a set of templates according to the connections in the scene graph, and finally, we fill the gaps in the template with the information on the graphs. Then, the generated scene description is going to be used in the QA module. The last branch, the recall branch, is the one in charge of searching for external knowledge that might be relevant to the video clip. We first build a knowledge base by downloading episode summaries from the internet. Differently from previous work, these summaries are not designed for the task of video story QA, and their information might be or might not be relevant to our questions. When an input video clip is given, the recall branch first conducts a video search to find to which episode the video clip belongs to, and then extracts a corresponding summary from the knowledge base. The summary is used in the QA module together with the subtitles and the generated scene description. Each input, which has the format of a natural language paragraph, is fed into a transformer together with the question and the candidate answers. The transformer for each branch produces a preliminary set of scores for each of the candidate answers, which are then fused together through a linear layer to predict the final answer. However, we have found that merging the three modalities together does not produce satisfactory results. This might be because the different modalities converge at different rates when optimized together. To address this issue, we use a modality weighting mechanism in which the scores output from each of the branch transformers are considered in the total loss. We evaluate role on the Knowit VideoQA dataset, which contains 4 types of questions. Role outperforms all the previous models by a large margin, even though the previous state-of-the-art model ROC used more specific human annotations as external knowledge. Even so, there is still a big margin when compared with human evaluation, so the task is still far from being solved. We also conducted experiments on the TVQA Plus dataset and compared our role model against TVQA and Stage. For a fair comparison, we did not use external knowledge in this evaluation. Even so, role also outperforms previous models. Now, let's watch some of the results.
It's always nice chatting with you, Sheldon.
Sarcasm?
Thinly veiled contempt.
To the question, who can we see holding a basket of laundry, the model answers Penny, as this information appears in the generated description, as we already highlighted. In the next example, to the question, where Sheldon, Raj, Howard, and Leonard having a meal, the generated description contains the necessary information to answer that this is the Caltech lunchroom. Finally, let me show you some of our relation study. In this graph, we show the performance on the Knowit VideoQA dataset with some of the branches are removed. The most contributed branch is the recall branch, which is according to the number of questions in the dataset. However, all the branches contribute to improve the results when used, which means that the model is taking advantage of the input from the 3 modalities. With respect to the fusion of methods in the QA module, we evaluate several choices, from basic averaging to our modality weighting mechanism. Many of the fusion methods were not able to outperform the accuracy of the best single branch, meaning that the different modalities are collapsing. In contrast, the modality weighting mechanism is able to successfully exploit the information from the 3 branches and obtains the best accuracy. As a takeaway of this presentation, we would like to highlight 4 main ideas. First, we introduce the idea of representing video with sentence descriptions without the need of annotations or supervision. Second, we represent all the information in the video clip as text to take advantage of strong pre-trained transformers. Third, it is possible to use knowledge bases without specific human annotations and using the resources already available online. And fourth, different modalities may converge at different rates, so it is a good idea to regularize the contribution of each of them in the loss function. Thank you very much for your attention. This is the end of the presentation, and we are welcoming you in the Zoom session.